Titrations. So a titration problem generally has the form of you have an unknown concentration and of either an acid or a base, and you titrate it with a known concentration of an acid or base. So this problem, you have a known concentration of a base, sodium hydroxide, and we have an unknown concentration of an acid, phosphoric acid. So the question is, what is the concentration of the unknown acid? So how you do titration problems, there's several steps, but step one is write a balanced chemical equation. So earlier, in an earlier play posit, you learned, or from class you learned, that when an acid reacts with a base, your two products are water and a salt. Now, we've got sodium here and phosphate here. So in order to get the salt correct, we have to balance the charges of the ions. Phosphate is a 3- charge. It's a polyatomic ion. Proton has a +1 charge, or a 1+ charge. 3 times +1 is +3. And then there's one phosphate. So phosphoric acid, H3PO4, is charge balanced. Sodium, +1 charge. Hydroxide, a -1 charge. Sodium phosphate. But as this is written, the charges are not balanced. So to balance it, charge-wise, polyatomic ions you must put in parentheses if there are more than one. In this one there isn't. So but 3 times +1 is +3. The whole phosphate anion has a -3 charge. That is the balanced, charge balanced sodium phosphate salt. Everything in frame. So now it has to be, the chemical equation must be balanced. The reactant side, 3 hydrogens, 1 phosphate, 1 sodium, 1 hydroxide. Product side, 1 hydrogen from the acid, 1 hydroxide, 3 sodium atoms, and 1 phosphate. I'm going to balance the hydrogen atoms first. 1 hydrogen from the acid, 3 here. changes the number of hydroxides. Now the equation is balanced. So this is a triprotic acid, phosphoric acid, 3 protons in it, hence the name triprotic. So this is the balanced chemical equation for this titration, for this acid-base reaction. So next is to use stoichiometry to find moles of unknown. So our unknown is the concentration of phosphoric acid. But what we do know is we have 125.4 milliliters of 0.150 molar sodium hydroxide. So we do know that. So I'm going to go ahead and convert milliliters to liters. There's 1,000 milliliters in a liter. So move that decimal over 3 places. That's how many liters of sodium hydroxide we have. Remember, molarity, this is the same as 0.150 moles in 1 liter. This number is the same as this. This can be used as a conversion factor. Liters are here, liters are here. We can use it. Contains 0.150 moles. So, using stoichiometry, the question's asking about the concentration of phosphoric acid. We know that we've got a ratio of 3 moles of sodium hydroxide react with 1 mole of phosphoric acid. We want units to cancel. Moles, sodium hydroxide, get units to cancel. 3 moles of sodium hydroxide, they react per 1 mole of phosphoric acid, H3PO4. If we do that math, I get 0.00627 moles of phosphoric acid. Now the question asks you for concentration. A molarity. Three. Use the molarity formula. find concentration. So molarity is equal to moles per liter. We just calculated moles, and we have the volume given in the question. Back at our volume. Milliliters of phosphoric acid. I'm going to convert 10 milliliters is that many liters. So the concentration of our unknown is 0.627 molar, or moles per liter. That is the process for how you solve and do a titration. Balanced chemical equation. Use stoichiometry to figure out how many moles of unknown reacted. Then use the volume of your unknown to figure out its concentration.